In this video, we are going to solve one-step linear inequalities. So at this point, you should know how to solve simple one-step equations. And luckily for the most part, solving one-step inequalities is pretty much the exact same process. There's a little bit of a difference, but it's pretty much the same thing. So what your gut is telling you to do is probably right. So if we look here at example 1, we see x plus 9 is less than 8. And hopefully your gut instinct is telling you to subtract 9 or to add a negative 9 to each side to get x alone. So we have x is less than negative 1. And that's correct. That's what our gut would tell us to do with an equation, and it's the exact same process for an inequality. Then from here, we're going to plot our answer on a number line. We have an open circle because there's no equal to, and then we're heading towards the numbers that are smaller than negative 1. Now if I look at the next one, hopefully your gut on number 2 is telling you to add 6 to each side so that these cancel out. So we have w is greater than or equal to 15. So there's our one-step solution. Then from there we want to plot all possible values for w on the number line. So we're going to plot those, put a closed circle because there's an equal to, and then we want to plot all of the values that are larger than 15. So we want to go towards the 17 because those numbers are larger. The next one, on number 3, we see 2y is greater than 8. Hopefully your gut is telling you to divide each side by 2. So we're left with y is greater than 4. Then we go to our number line. We have 4, I'm going to do 6 and 2. We have an open circle at 4, and then we want all of the numbers that are bigger than 4. Those will represent y. And then finally over here in number 4, we see m divided by 5 is less than or equal to 3. So we're going to multiply each side by 5 to undo that division. We get m is less than or equal to 15. And then we go to our number line. We have 15. We're going to have a closed circle at 15 due to the equal to, and then we want all of the numbers for m to be less than or equal to 15. So if you know how to solve equations, solving inequalities is essentially the same process. There's just one small difference, and we'll talk about that on the next slide. So as I said before, solving equations is just like solving inequalities, except for one small difference. So this is the part you really want to make sure you take note on. Every time we undo multiplication or division of a negative, so this is saying every time we multiply or divide each side by a negative number. So we have to undo a multiplication or undo a division of a negative number. Every time we multiply or divide each side of the inequality by a negative number, we must flip the inequality. So we'll look at a couple of different examples and talk through how we know when we do flip the sign and how we know when we shouldn't flip the sign. So looking here at number 6, we see that we have x divided by 3 is greater than negative 4. And in order to get the x alone, we're going to have to multiply both sides by a positive 3. And notice, we're multiplying both sides by a positive. And what this means is that we do not flip the sign. We leave it alone. Even though we get an answer of x is greater than negative 12, even though we get an answer that contains a negative number, because we multiplied both sides by a positive, our sign stays the same. And then from here, we can plot our number on the number line. We put an open circle, and then we want to head towards the numbers that are larger than negative 12, which are numbers like negative 10, negative 8, 0, anything positive. Now if we take a look at number 7 here, I notice that I have 4x is less than or equal to negative 12. We're going to start by getting the x alone by undoing the multiplication and dividing both sides by 4. Since we're dividing both sides by a positive number, we do not flip the sign. So we leave it here as is. So we get x is less than or equal to negative 3. So we go to our number line, we plot, we have a closed circle at negative 3, and then I want numbers smaller than negative 3, so that's negative 5. All right, down here in number 8, I need to undo a multiplication of negative 2 by dividing both sides by a negative. So notice that I divided both sides by a negative here. When I do that, that is an instance where my sign is going to flip to the other direction. So as we divide by a negative on both sides, we end up with x on the left, we end up with -4 on the right, and then as a result, we've flipped our sign because we divided both sides by a negative number. So then from here, we go plot our solution. So we have -4, -2, -6. We have an open circle, and we go less than. And finally, in number 9 here, we need to undo a division of -3. So we're going to multiply both sides by a -3. Notice we're multiplying both sides by a negative. And our rule says if we multiply or divide both sides by a negative number, that is when we do in fact flip the sign. So here we're going to flip the sign around. On the left side, we're left with x. On the right side, we're left with -6. And then from here, we can plot, and so we have a closed circle because of the equal to. We want all of the numbers less than -6. So again, you're looking for when you multiply or divide both sides by a negative number. That's when you flip your inequality symbol. And to end here, we're going to look at 2 different inequality word problems. So what's going to happen is we're going to read through, we're going to write an inequality to represent that situation, and then from there we're going to solve the question that it's asking us to solve. So here it says we have $90 to buy CDs for your friends. And CDs cost $14 each. What are the possible numbers of CDs that you can buy? And the part that tells us this is an inequality is that possible numbers piece. What are the possible numbers of CDs you could buy? That's saying you could have one number that you could buy, but you could have multiple different options for how many CDs you could buy in that store. So let's start with the key important information I see. I know that there are $90 to spend. So this is what is in my purse currently. That's how much money I have. And the cost of CDs is calculated by taking $14 and multiplying it by the number of CDs that I have. So this is my cost. And if I think about this, I have $90 in my purse. That's it. I can't spend more than $90 because I don't have anything else. If I try to spend more than $90, I'm going to run out of money and I won't be able to make the purchase. So I need to put an inequality in here, and by thinking it through, I think, well, my cost, which is this right-hand side here, my cost needs to be less than the $90 that's currently in my purse or equal to it. I can spend $90, but I could spend less than $90. Whatever it is, this right-hand side of the equation can't go over $90 because I will run out of money, and 14 times C is my cost. So here's my inequality, and this should make sense to you in the store because I'm not required to spend $90. I just need to make sure I spend $90 or less, hence the inequality and not the equal sign. So now I'm going to actually work through and solve this. I'm going to divide both sides by 14 to get C alone. So 90 divided by 14 leaves me with about 6.429. And then if you don't like the C on that side of the inequality, notice the C is on the smaller side. So I can rewrite this as C is less than or equal to 6.429. And you might be thinking this answer is a little bit weird. But actually, in the real world, this makes the most sense. So what this is saying is I could buy 6 CDs or less. That's what this statement is saying. And if you think about the real world, this makes sense. You could go into that store and you could buy 0 CDs, you could buy 1 CD, you could buy 2 CDs, you could buy 3, 4, 5, or 6 CDs, but you couldn't buy more than 6 because you would run out of money. So you could buy any combination of these depending on what you found. You could buy any combination of them. You could buy 0 CDs because you found no CDs that you wanted, or you could buy 6 and spend as much money as possible. All right, last word problem. It says you are checking a bag at the airport. Bags can weigh no more than 50 pounds. Your bag currently weighs 16.8 pounds. Find the possible weights W that you can add to your bag before you will pay an extra fine. So, I'm going to put the 50 over here. This 50 is the max weight before we have to pay a fine, and we don't want to pay a fine. So 50 is our max weight. Now, our bag currently sits at 16.8 pounds. So this is our bag. And we're going to add some weight to it. We don't know how much weight we're going to add, but we're going to add some weight to it. So our bag has 16.8 pounds, and we're going to add something to it. But the maximum that we can be is 50. So we can't go over 50. This is us. We can't go over 50, which means we need to be less than or equal to 50 pounds. Otherwise, if we're not less than or equal to 50 pounds, we're going to go over and we're going to get charged an extra fee. So from here, now that I have my situation set up, I can take 50 and I can subtract 16.8 from it. And I get 33.2 is less than or equal to W. And then if I don't like the way that's written, I can say W is on the smaller side of 33.2. And if we take time to think about this, what this is really saying is that we could add 33.2 pounds or less to our bag, and we would still make the cut. If we add more than 33.2 pounds, we're going to go over it. But if we add 33.2 pounds or less, we'll stay under the threshold of 50, and our bag will be able to be on that plane without an extra cost.